Okay, so this video is basically about graphing the compound inequalities that you've been solving. So I have a couple of examples for us. We have the first compound inequality here is z plus 2 is greater than 7 and z plus 2 is less than or equal to 11. So if you solve each of those pieces, algebraically here we're subtracting 2 from both sides. Same thing here, subtracting 2 from both sides, you end up with z is greater than 5 and z is less than or equal to 9. So if I go to graph those things, graph those equations down here, first I'm going to graph z is greater than 5. So I'm going to go to 5, I'm going to put an open circle, and then that would be greater than 5 would be anything to the right of that open circle. So something like that. And that would continue on forever all the way, anything over here on the number line. Then if I'm going to do the blue, I have z is less than or equal to 9. So if I go to 9, I'm going to do an open circle at 9 and actually shade it in because of this or equal to line right there. And less than 9 is numbers going this way on the number line to the left. So it looks something like that. So now with your compound inequalities, once you've graphed both of those, you have to go through and say, like, for an and statement, you have to go through and say, where did they overlap? Because the overlap are the numbers that are both greater than 5 and less than 9 or equal to 9 at the same time. They have to do both. So that's just going to be here in the middle where you have this overlap happening, and 9 would be included in your solution set because of this or equal to, but 5 has that open circle, so it has that still open circle boundary. So you're looking at just where both regions of shading happen. That's for an and statement. An or statement looks a little different. Here's an example of an or statement that I've already solved here. So I added the 7 to both sides and then divided by 8, or I'm sorry, divided by 4 to get to 8. Here I subtracted the 12 from both sides and then divided by -9, and then pay special attention there because when you divide by that -9, your sign has to change direction. Anytime you divide or multiply by a number that is negative, you have to change your sign. So pay special attention to that. So when I go to graph those, if I graph ends that are less than or equal to 8, that's a closed circle at 8 with everything to the left shaded. And then I have to come and graph n less than or equal to -2, which again, we have a closed circle here, and then everything to the left shaded. So for an or statement, what that means is that anything that is shaded, either in red or blue, is part of our solution set because either or is fine. So that would mean that my final answer for this problem would be all these numbers here. Final answer would be anything that is less than or equal to 8, because any number that is less than or equal to 8 is also less than or equal to -2. We only have this one direction of shading. It is possible with an or statement that you end up with something that looks like this, where our arrows are going in opposite directions. And so our final answer for that or statement would be anything that is greater than 5 or anything that is less than 4. So we have this little gap here in our shading in between 4 and 5, but everything else, every other number will work. So that would be for like an or statement. But if I take this exact same question and I change it so that it's an and statement, all of a sudden I have no overlap on my graph. And so that is a situation where you have no solution if it's an and statement. So I hope that helps clarify where we should be shading on our inequalities, and we'll see you next time.